When the size of the particle is in this range, we adopt certain methods. So here, size of the nucleus, as you all know, that is 10 raised to minus 15. Similarly, 10 raised to minus 10 meter can be called as 1 angstrom. Mass, it is the number of molecules present in certain matter. Hello everyone, I am Rinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to the session 2 of chapter 2, that is Units and Measurements. Here in this session, we are discussing the range of size, length and mass. In the previous class, we had studied the units, which are the units for specified base units, and which system of units are we using, that is system international unit we are using. Okay, in this chapter, let us study estimation of small sized particles. In this chapter, units and measurement, we are studying estimation of small particles. Here, we know that we will estimate the size of certain things which are visible to our eyes. We can even estimate the size of a scale or a pen or pencil or a book which you are having, all those things. We can estimate the size of the ones which are greater in size, larger in size, okay? When it comes to the smallest particle, how do you estimate the size of the smallest particle? Sometimes it is even invisible to our eyes. That is by using microscope. So there is an instrument in order to measure the size of the smallest particle. Here that instrument is called as microscope. So there are a variety of microscope for certain particles or the certain object which we are identifying. So let us study to measure a small size of certain range. So that range is like 10 raised to minus 8 meters to 10 raised to minus 10 meters. When the size of the particle is in this range, we adopt certain methods. So that special method is by using this microscope. So there are too many types of microscope which can resolve particles of certain range. It has got certain ranges. Each and every microscope, it can resolve particles up till certain range. So coming to 3 types of microscope which we are studying today, that is optical microscope, electron microscope as well as tunneling microscope. Optical microscope, okay, optics. So what does it involve? It involves light. So this optical microscope uses the visible light. So the range is like 4000 angstrom to 7000 angstrom. Okay, so this is the range of the optical microscope. So it can resolve particles which is within this range. Above this range or below this range, it cannot resolve the particles. Okay, so this is how it is. Optical microscope uses visible light. Okay, so next is angstrom. What is this angstrom? So 1 angstrom is nothing but 10 raised to minus 10 meter. Okay, so this is how the optical microscope works. Okay, next coming to electron microscope. So why is this electron microscope used and what does it uses? Since like optical microscope uses visible light, in similar way electron microscope uses electron beam, and that is focused properly by the well-designed electric as well as magnetic field. This electron microscope is used for the particles under certain range. But here, this resolution of electron microscope is said to be limited. That is because the electrons behave as waves, because of which the resolution is said to be limited. So this electron microscope can resolve atoms and molecules. So the tunneling microscope, this is used in order to resolve certain molecules within certain range. It has better resolution than the angstrom, and it is used in order to resolve the size of the molecule. Okay, so in order to estimate a very small size of a molecule, we opt for an instrument called as microscope. So microscope can be three types: optical microscope or electron microscope and tunneling microscope. There are too many microscopes. We are studying only these many microscopes now. So optical microscope uses visible light and it can resolve the particles which are under certain range, and electron microscope, it uses electron beam and it is focused by a well-designed electric as well as magnetic field, and it can resolve atom or molecule. It is used to estimate the size of the atom or molecule. When it comes to tunneling microscope, nowadays recently they are using tunneling microscope because its resolution is better than the angstrom. Okay, so the tunneling microscope here, it is used to estimate the size of certain molecule within certain range. Okay, so that is how you detect the size of the smaller particles. So coming to the next, that is range of length. Let us check the range of length. So size of different objects varies. That is, from certain range to certain range, each and every size of each and every physical things or physical object varies. So certain ranges it's given mentioned here, that is it varies from 10 raised to minus 15 meter, that is the range size of the nucleus, to 10 raised to 26 meter, that is the size of the observable universe, the distance, the length of the observable universe. So here size of the nucleus, as you all know, that is 10 raised to minus 15. Unit is must and should, that is meter. So everywhere unit is must and should. Okay, so this is meters. Size of the nucleus is 10 raised to minus 15 meters. Size of the hydrogen atom is 10 raised to minus 10 meters. It keeps on increasing. So see, radius of the earth, everything is given in the table which you can visualize here. So distance to the boundary of observable universe, that is at last we have 10 raised to 26 meter. That is from least to the highest range. It is in the ascending order, that is from least to highest. So you can check. So what is this observable universe? Observable universe is a universe which contains the matter which we can observe through space-based telescopes, okay, which is observed through the telescope. So the observable universe is a universe which is observed through telescope, by the help of a telescope, and we can see which consists of matter which is observed. Okay, so that is nothing but observable universe, which can be, the range of observable universe can be 10 raised to 26 meter. So coming to the next topic, that is range of length. There are some special length which can be represented in this way. That is, some special length units are used for short as well as larger length. In short, there is a certain name for it. So that we are studying here. So when it is 10 raised to minus 15 m, in short, we can call it as 1 Fermi. Fermi means it is raised to minus 15. 10 raised to minus 15 is called as Fermi. Coming to angstrom. So what is 1 angstrom? 1 angstrom's value is 10 raised to minus 10 meter. We can call it as 1 angstrom in short. Okay. So some special methods which we are adapting in order to represent few lengths, that is 10 raised to minus 15 meter, can be called as 1 Fermi. Similarly, 10 raised to minus 10 meter can be called as 1 angstrom. Coming to 1 astronomical unit. So what is this 1 astronomical unit? So it is the distance. So this is your sun and this is your earth. So 1 astronomical unit is the distance of sun from the earth. So this distance is called as 1 astronomical unit. So that is equal to 1.496 into 10 raised to 11 meters. So this we can call it as 1 astronomical unit. So now coming to 1 light years. So what is this 1 light year? You all know the velocity of light is 3 into 10 raised to 8 meter per second. So this is the velocity of light. So what is this 1 light year and how is it related to the velocity of light? Yes, it is like the 1 light year. The light travels with the speed of 3 into 10 raised to 8 meter per second throughout the year. That one is known as 1 light year. In a year, light travels in this speed, that is 3 into 10 raised to 8 meter per second. So that value is given as 9.46 into 10 raised to 15 meter. So the distance traveled by the light with certain velocity, the distance traveled by the light with certain velocity in 1 year is given by this value, that is 9.46 into 10 raised to 15 meters. So that is called as 1 light year. Similarly, 1 parsec. The value of 1 parsec is 3.08 into 10 raised to 16 meters. Okay, so that is 1 parsec. So what is this parsec? So parsec, it is the distance at which the radius of Earth's orbit. Parsec means it is the distance at which the radius of Earth's orbit, distance at which the radius of the Earth's orbit, Earth orbits, right? Its radius we are taking, it subtends an angle of arc second. Subtends an angle of arc second. That is called as parsec. So 1 parsec, it is the distance at which the average radius of Earth orbit is considered. So it is the average radius of the Earth's orbit. It subtends an angle. It subtends an angle of arc second. So that is called as parsec, and 1 parsec value is 3.08 into 10 raised to 16 meters. Coming to the measurement of mass. So what is this mass? Mass, it is the molecules which is present in certain physical quantity. So there is a difference between mass as well as weight. Mass and weight are not one and the same. Mass is different than weight because mass, it is the number of molecules present in certain matter, whereas the weight, it depends on the gravitational force applied in certain region. Okay, it depends on gravitational force. Which one? Weight depends on gravitational force, whereas the mass doesn't depend on the gravitational force. It is the presence of molecules in certain object. Okay, so what is mass? It is the property of a matter. So there might be change in weight in certain planets. It is like the weight in Earth may differ when compared to that of a weight in Moon, whereas in case of mass, it is one and the same throughout. So it is the property of a matter. Okay, so the mass doesn't depend on temperature, it does not depend on the pressure or the location in space. It is independent of temperature, pressure and location in space. So what is mass? It is the property of a matter and it doesn't depend, or it is independent of temperature, pressure or location in space. So in order to calculate this mass, what is the unit you use? Okay, it is kilogram. It is kg. In short, you call it as kg. It is the kilogram what you use. SI unit of mass is kilograms. So mass is defined by taking a fixed value. So by taking a fixed value, we can define a mass, that is by taking h. So what is this h? It is called as Planck's constant. H is nothing but Planck constant, and the value of the fixed value of H is 6.626 into 10 raised to minus 34 joules. Okay, it is 6.626 into 10 raised to minus 34 joules, or it also can be written as kg meter square second inverse. So this is the value of Planck's constant. So I hope you all got to know what is mass and difference between mass as well as weight. Okay, so mass, it is the property of a matter. Okay, it's a molecules, number of molecules which is present over in the matter. So it is not depending on temperature or location in space or anything, because it has got certain fixed quantity, okay, which doesn't change. It is not depending on any other factors which is present over here. So SI unit of mass can be kilograms. It is kilograms, and the symbol used is kg. Okay, so here in order to define mass, what do? We just take a fixed value. That fixed value can be h. So what is h? That is Planck's constant. The value of h is fixed. It has got a fixed value, constant value, that is 6.626 into 10 raised to minus 34 joules, or instead of joules, you can even give kg meter square second inverse. So next, you're going to measurement of mass again. So the previous slide we had studied what is the measurement of mass, right? It is applied for a matter for the size of certain range which can be measured. In case of very smaller sized particles like atoms or molecules, we have to adapt ourselves to a other method. So what is the method used to measure the mass of atoms or molecules? That is tiny particles. That is atomic mass unit method. So kilogram, it is an inconvenient unit in order to measure the atoms or molecules. Can you tell this atom has so many kgs? No. This molecule has so many kgs? No. So kilogram, it is an inconvenient unit in order to measure the mass of the atoms and molecules. So the method what we adapt is called as atomic mass unit. So it is 1 atomic mass unit is considered to be 1/12 of mass of an atom of carbon-12 isotope. Of which atom? Carbon-12 isotope. So 1 atomic mass unit is considered to be 1/12 of mass of the atom of carbon-12 isotope. So that is what it is. So 1 atomic mass unit is equal to 1/12 the mass of an atom of which isotope? Carbon-12 isotope. Okay. So 1 atomic mass unit is nothing but 1.66 into 10 raised to minus 27 kg. So that is the value of 1 atomic mass unit. This is the method in order to estimate the mass of atoms or molecules, that is the smallest particles. Okay. So next let us go, which are the instrument in order to determine or in order to identify certain mass of particles. There are few instruments which are used to determine the mass of the objects or the particles. So here one method is weight balance. Usually you have seen in grocery shops and all the weight balance. They use this weight balance which is visualized here in this image. So this pictorial representation gives you the idea. So this is nothing but weight balance. You all have seen this weight balance and you all know how they use it in grocery shop or in vegetable shop or in any other shops. Okay. So next is gravitational method. So this is used for the objects, objects of what size. Okay. So coming to gravitational method, it is used in order to measure the mass of the planet. Gravitational method is the method which is used to observe the mass of the planets. Okay, so what is the method they undertake? That is, they just compare with one to the other. That is, they compare the force of gravity of an unknown planet or an unknown object with that of the force of gravity of the known object. So in comparison, they get the mass of the object, that is by using gravitational method. Then third one, it is mass spectrography. That is this method wherein it is used to identify, this technique is used to identify the mass to charge ratio of the ions. Mass to charge ratio. So in this mass spectrography, what is the principle used? That is, the principle what it uses is the moving ions may be deflected by electric as well as magnetic field, and it is used to determine the mass to charge ratio of ions. So this is the mass spectrography methods where the sample is sent here and the ionization takes place after acceleration. Then electromagnet is used to focus the beam properly and finally it is amplified here and it is recorded. So this is how the procedure is taken place. So the commonly used instruments are weight balance, as you all know, you have seen that, and gravitational method, I told you it is a comparison of one object to the other, that is of unknown to the force of gravity of the known. By that you will get to know the mass of any object what you are identifying. So it is used to measure the mass of the planet, whereas lastly we are studying about mass spectrography. It is the technique which is used to estimate the mass to charge ratio of the ions. So this is the method what it undergoes. So now let us study the range of masses of the surrounding objects which are available in the surroundings. Those are like electrons, that is 10 raised to minus 30. It is its mass. Whereas proton, it is minus 10 raised to minus 27. Likewise, red blood cells, it is 10 raised to minus 13. Raindrop, it is 10 raised to minus 6. Similarly, at last, it is Milky Way galaxy. Its range of mass can be 10 raised to 55. So in today's class, we have studied how to estimate the size of the particles which are smaller in size and up to certain ranges, and we have studied the range of length of certain particles and studied about mass and dependence of mass and the units of mass as well as the instrument which are used to determine the mass of certain objects and range of the mass which the object which is surrounded by us. So that's all for today. Have a good day. Thank you.